Hello, this is Jian Zhang from entire PRC team, actually based in Shanghai. I'm currently the software engineering manager of Ceph development team. We are doing a lot of code contribution to the Ceph community. Today I'm going to introduce a tool. Previously we called it CephPerf, but recently we changed the code name to CeTune, which is a user-friendly Ceph performance and profiling and tuning framework. So let's start. This is some background. At first, I'd like to give a brief introduction over what is Ceph. Ceph is actually an open source, massively scalable and software-defined storage system. It is the most popular block storage backend for OpenStack-based cloud storage solution now, so that's why we are here. But and Ceph is also an important component of the Intel software-defined storage strategy. So although Ceph is very popular, but there are still many problems. The end user face numerous of problems that when they are trying to drive the best performance through the Ceph cluster. So we have met increasing requests from the end user on how to troubleshooting the Ceph cluster, how to identify the best tuning knobs from the 500 parameters, and how to handle the unexpected performance degradation from frequent releases. So to answer those questions or solve those issues, we proposed a framework called CeTune, which is to profiling and tuning the entire Ceph cluster's performance issues. The purpose of this is we can shorten the end user's learning time of the Ceph-based storage solution, and we can close the enterprise readiness gap for Ceph, which is mainly about stability, usability, and performance, and etc. And we can build an optimized IA-based reference architecture and influence customer to adopt it. So of the right picture, we can see we can tune the Ceph clusters many kind of components, including the file system level, the parameters, and the deployment. We can propose best configuration for the Ceph cluster, and we provide a UI interface for the benchmarking and analyze tuning, which can easily do the profiling job, and based on this, we can get a performance boost over the Ceph cluster. So this is a general framework of the CeTune. So it actually contains 5 different components. The first one is called deployer, which can deploy entire Ceph cluster in a single click. It can shorten the deployment time from 1 week to 1 single hour. And the second thing is called benchmarker, which includes the object storage, the file system, the block storage. We can cover the 3 different kind of interfaces. Currently, we support the cost bench as the object storage benchmarker. We support the FIO with label IBD, FIO with kernel IBD, FIO with QEMU IBD as a block driver, and we also support FIO with label CephFS as a file system benchmarker. And with those benchmark workload, we can analyze the result, which is based on a web-based UI to see the throughput, the latency, and then we can analyze the result. With those kind of things, we have a tuner. The tuner, we can try different configurations, different kind of parameters, and then identify the one that impact the performance. We can make sure we can get the best tuning knobs from different parameters. The last part is the visualizer. The visualizer is actually help the end user to visualize the throughput and metrics in a single centralized web-based UI. So the right bottom picture is actually about the entire flow of how the CeTune works. Actually, we have a controller running on the single controller node. It will read the configuration file from a single file, and then use PDSH to distribute those kind of configuration files to different CeTune workers. And then those workers can collect the needed metrics from the OSD node and the monitor, and then send it back to the controller for post-processing. Okay, here is the detailed configuration of the CeTune configuration file. Currently, it supports the red table is mainly on how to deploy a cluster. We can specify the Ceph versions, we can specify the monitor servers, and OSD server, the RBD node, and we can define the journal and the disk mapping relationship, and we can see the OSD size, the OSD partition size. With this cited, we can kick off the benchmarking part. The red table is actually about how many virtual machines we are going to deploy, and how many clients we are going to use, and what's the load run, what's the load level we are going to test it against those kind of volume services. Actually, we can run different number of virtual machines, we can run different volume size, we can run different I/O pattern. Based on our customers' input, we basically propose 4 I/O pattern, which is sequential write, sequential read, and random write. So we define different record size for those kind of different I/O pattern. And with this, we can simulate a real user scenario to testing the cluster's performance. The following page is basically about one-page introduction of each of the components. The first one is the deployment. We can see this basically doing the same job as Ceph deploy. The first thing when we deploy a Ceph cluster, the oldest way is we use the Ceph deploy command line to deploy each component to put those OSDs to make the file system, which is pretty slow, and sometimes people met a lot of bugs and issues. So with CeTune, it can automatically deploy the related libraries, and including the developer library, and including those kind of metric collecting tool packages like sysstate, iostate, SAR, and it also can providing a benchmarking installation guide to help the end user to understanding the entire thing. And after that, it will deploy the Ceph by Ceph deploy. And currently, it also supports the Ceph benchmarking tool. Okay, with this deploy thing, we can deploy the Ceph cluster with one click, and building the OSD monitors, daemons, and planning the default tuning knobs we have. And after that, all we need to do is wait till the cluster become health okay for performance benchmarking. For this benchmarking part, it's pretty simple. Currently, we support all the 3 storage interfaces in Ceph, and what we do is for the first prepare page, we can create an RBD volume and initiate, and then create the virtual machines and mount the volumes to the virtual machine. After that, we can do the testing job, which we can run FIO in block, and we can also run FIO and VD bench for CephFS system, and we can use cost bench against the RGW or Liberados plugin for the object storage. The left picture is actually about the log info. We can see there are yellow lines highlighted which state we are, and with this thing, we can easily kick off the benchmarking. And for each single run, there will be a run ID to identify that benchmark, and all the result is archived in the different folders, indicating whether it's an OSD node or client node, and with the Excel file containing all the results. And for the analyzer thing, although it's still work in progress, and what we think most important for the developer or the end user is how they can identify the performance bottlenecks. With this CeTune thing, it provides a latency breakdown and provide a function level analysis. So we kind of think the first part is about system level metrics, and then we have the function level and the detail latency level analysis. So with this thing, we can easily identify which process consumes most of the CPU utilization, and which part has the highest latency. And for this, actually based on the Zipkin. Zipkin can post-processing the latency data we collected, and when we click one of those points, it can review the entire latency breakdown for a single OP request. With this, it's pretty helpful for us to identify something like spin logs and the queue, the switching thing. For the tuner thing, it's pretty simple, and it kind of iterates from the different configurations from the all.conf file and automatically generates the tuner conf file and with some tuning reference. And the main use of the tuner thing is we can test the Ceph cluster with different configurations, with different Ceph versions, with different deployment configurations. The end user can define a bunch of test jobs here. And with this is an example of what we can do, how we can use the tuner to identify some kind of tuning knobs. For example, when we increase the placement group number, we can significantly improve the performance for 4K random read, and because the default value is far way below, far way small. And when we trying to mapping or storing the OMAP data on a separate hard drive or separate SSD, we can significantly improve the throughput because we can let the metadata operations on the key value database much faster. When we use the read head, it can also increase the sequential read performance because it kind of like improve the sequential operations on the OSD side. Now when we're using the IO merge and the write catch chain, we can also improve the write sequential write performance a lot. The last thing is actually about the visualizer. The visualizer will aggregate all the throughput, all the system level metrics, and also providing a detailed latency breakdown through the web-based UI. So it's kind of like the end user only need to go into this web controller and see all the results. Oh, it can easily help them to identify the CPU utilization, timeline, and the throughput timeline, output latency timeline, etc. And with this, they can easily identify the performance issues. Okay, so here comes the summary. We know that Ceph is the most popular block storage solution for OpenStack, and although it is the most popular, but due to the complexity and the many parameters, we need a tool for Ceph performance benchmarking, profiling, and tuning. So here comes out CeTune. It is a powerful tool for Ceph profiling and tuning. So it will be open sourced in 8th of June. Any questions, just contact me at this email address if you are interested. Okay. Thank you.